Everyone. So the next presentation is from IBM. Vidya is going to talk about the topic of the presentation is autonomic notification framework for performance elevation in applications in cloud. Yeah, Vidya.
Good morning again. So today we are going to discuss about the need for autonomic framework for performance elevations of applications at a layer below the application layer. The question will be, why do we need a performance elevation layer below the application layer for elevation of performance on the application layer? We will discuss and understand the need. So the agenda will be to discuss about autonomic notification. We'll walk through on what this keyword autonomic exactly means, and the performance factors that are influencing the applications, use cases, a minute intro for the autonomic computing keyword. I'll not go in deep about the notification framework implementation, but give you a highlight of how it has been implemented on the Unix flavor of IBM, that is AIX. Would be more interested in discussing about the experimental results and then take the questions. So before we go into the need for autonomic notification of applications in the cloud, we'll discuss about why a need is there. So all of us are interested in the notification of any event in real time. The notification of event can be such that you have e-commerce website, you have Flipkart going on some sale, you would be interested on a particular product for which you would need notification, and when the event happens. What do? You go and add it to the wish list, or you go and register yourself for such a notification. An update would be sent to you to your device or gadget that you have registered to, and this is frequent. This normally is called observer pattern in the application layer. So such notification happens to us in the day-to-day event also. That is, we need notification to wake up in the morning, we have alarms. So it's part and parcel of our daily life. So such notification mechanism is what I am going to talk about for all the applications, irrespective of the type. It can be a database application, it can be a network application, or any application that would leverage this infrastructure that is built on a layer below the application layer. So we are talking about a layer in the operating system implementation that is on the top, which is the application layer. Below the application layer is called a privileged layer, that is the kernel. And below the kernel you have the hypervisor, which manages all your hardware or the logical or partitions. 42% of, we have had a survey, the normal survey that happens is 42% of the application layer, the business that happens in any organization is dependent on the uptime or the downtime of the infrastructure. With growing data center, we have the number of resources in the data center that would have applications running on them and are dependent on quick and fast results. We can't wait. We just can't wait. Nobody can wait. So the downtime is actually 42% of downtime will cost more than $1 lakh per year is what Forrester is saying. This is 2011 report. With 2011 report, we have 2013 report from Gartner also, which says there are about 7 important requirements for any application in the cloud that need to be critically managed by the service provider. One of the topmost requirement is performance, in addition to whatever called security or integrity or many more. I'm not discussing in detail because we all know about it. So cloud, When we talk about cloud, cloud is a bunch of nodes. They are interconnected logically and they have to interact with each other without any time gap. Here is what performance plays a very important role for all those players who are sitting and leveraging cloud apps. Maybe it can be SaaS, it can be PaaS, platform as a device, or infrastructure as a device, and so on. Yeah. Factors influencing performance. And performance of an application can be of two types. If we have ever thought of designing an application, we would normally encounter with few internal factors of the design of the application. We go ahead and write a design document and come up with the functional requirements and say, yeah, it should have a better form of data structure, not go for a linked list, let's go for a binary tree for a better OOFN complexity. We better have good allocation mechanism. We'll not go for the Yorktown mechanism, we'll go for a red-black tree kind of mechanism. The aligned access for data, how you read and write the data. The read and write of the data has to happen at a aligned boundary. It has to be a word boundary or a double word boundary, basically 8 byte or 16 byte. Otherwise, what the CPU, the processor will do is it will do half read and then again go and fetch the remaining half read. The merger will take time, it influences the performance. So some of the influencing internal factors are what I have put here, and the external factors are of course network, the CPU performance, not only the CPU performance, the number of CPUs that can provide on-demand requirements for the application for processing the threads, and so on. So we'll talk about one important example of factor influencing the performance of CPU with applications and need for change, and another factor with internal factors. So both external factor and internal factor implementation and impact with respect to the framework that I have developed for AIX will be discussed. So this is the use case that talks about internal factors. Consider you have n number of CPUs and you have m number of threads. So the number of threads that can perform, context switching depends on the number of processes, threads that are there in your processing queue. That's called run queue. Now, if the number of CPUs on the system is increased, we have a mechanism called on-demand capacity. We go ahead and add number of CPUs, but the application is not aware of number of CPUs that has been added. It just keeps blindly running, assuming that, the change, because you have a thread pool size defined, and the thread pool size is not modified. So this framework would tell the attribute that has changed is the number of threads that can access with the number of increase in number of CPUs. So your thread pool size can increase, you can have your pool size, the number of threads can be increased. You can have, if you say you have 20 threads, a thread pool of 20 threads and your CPU is added, you can have another thread pool of another 10, so it can be 30, wherein the 30 threads are waiting for some process to be executed. Do we have any questions here? Maybe later. Oh, sorry. Sorry? User space. User space. The thread pool is defined in the user space. You have an application, you have threads defined. So it's a basically pthread library. I am not talking about Unix alone. It can be generalized to any operating system. It can be a threaded library. Sorry. Maybe I'll go this time. autonomic keyword is a buzzword that we have heard about a decade back, and this was in the era of 2005, and then came the cloud computing and so on. So there are four backgrounds to autonomic computing. It says that autonomic computing for applications are self configuring, that is a capacity for an application to configure itself depending upon the external influencing factors. Self healing, that's when it's going sick, the health check happens, it can heal itself or take corrective or preventive measures by itself, is self healing attribute of autonomic computing. And then you have the self production, that's when you have a panic, like you have a sick danger or you have paging space of the OS coming down and you have sick danger. How do you handle the signal? You have mechanism to handle these kind of panics with signal handlers and so on. So that's autonomic self-production mechanism and self-optimization. Self-optimization is if my attribute is changing, a number of CPUs are changing, I go ahead and optimize myself to increase the thread pool size and processes accordingly. So autonomic computing in cloud are hand-in-hand technologies which are very essential for performance elevation. Okay, there are various mechanisms to in fact implement this. Some of the known techniques are existing in the market are dynamic reconfiguration. Dynamic reconfiguration is a solution wherein you have some application getting aware of some changes in the CPU, change in demand, but all of these mechanisms with respect to dynamic configuration are hardware based. What distinguishing factor we have here in this framework with respect to notification is that it is software based also. So we are going to see how the layer below the kernel impacts changes in the kernel space, the software layer, not just the hardware. The number of CPUs changing or the network card added is what dynamic configuration was taking care of. Here in this framework, we have the software notification, that is what is placing a unique difference. I will directly go to the examples and then come back to the sequence of implementations which makes more clearer. I have to switch slides here now. Okay, I think this is the last slide that I have put. Yeah. So what we did was we went ahead and implemented a multi-threaded application that would show the performance elevation of CPU variations. We had two CPUs with the thread constrained thread size, thread pool size, not the thread size, thread pool size, and with and without this application framework implementation is what is discussed in the graph here. Until the CPU size went up to 128, there has been no slack. You can see a logarithmic table here. So this shows that the trend of the graph is the time taken for execution versus the number of thread the application were using for a matrix multiplication. So it was consistently performing well. On the other case, it was going down. This is a good example of the internal factor that is influencing. Now we have the application layer. So bunch of nodes in the network or the cloud interconnected with each other, as you see in figure 1. Yeah, as you see in figure 1, you have node 1, node 2 and node 3. They are systems that are interconnected in the cloud and they talk to each other continuously. They do interact with each other and tell about their health condition by mechanism of what is known as heartbeat. They send heartbeat to each other and every nanosecond they say they are alive. Based on the availability, this is a high availability technology which does synchronization pretty often. So, this is referred to as a cluster of nodes. What normally happens is the nodes that I am talking about are partitions. Node N1 might change its attribute which system node N2 and N3 may not be aware of. So, how does this happen? This change has happened sometime sporadically and the information or the event change are communicated to other nodes N2 and N3 asynchronously and or by intervention of the some daemon that is running at some event. Okay. So, if N1 has changed, here I have given an example, if N1 has changed its host name or the system name to n1.ibm.com, then N2 and N3 are informed about the change, let us say about 10 minutes after the change has happened. And because this happens, there is a disconnect between the packets that are exchanged between each other and it probably most likely will tell that node N1 is down. This breaks the high availability system and then it causes lot of impact for backup and recovery and so on. So, it is very important that we have clusters synchronized very instantly and immediately. Our framework will talk about how this has been implemented. Now, this figure 2 talks about the kernel layer on one side and the application layer on the other side. So, you have the kernel, you have a system call. So, every application which requires some privileged access to the kernel goes through a system call. This takes the privileged system call set hostname or hostname or whatever. Now, it does a copy in, okay, let us not bother about that. We will come back to the slide again. So, you have the notification layer embedded here in the system call. Now, this changes the host name and immediately informs the cluster. That is, the node N1 in the cluster gets notification. Now, what does this do? There is a daemon that is running on node N1 that is waiting for this event. It picks it up and it sends the information to other nodes instantly. It happens in fraction of seconds. That way, we do not have to wait for 10 minutes for somebody polling and verifying if any attribute has changed. Somebody in the sense some application, some other application in the host. So, we avoid something known as select and poll and manual verification and so on.
Or is N1 just one machine?
It's just one machine.
Okay. So you have to do that for every single machine in that node, or are you defining node as a machine?
N1 is a machine. It has user space and the kernel space. It has a host name. N1 is the host name. I have changed N1 to N1.gracehopper. Now it has to update N2, which is another single machine, and N3 is another single machine. These are connected.
So
because they are
how will
sending.
you scale this then? How will you scale this? Maybe you already covered it, but just when you're looking at this, it seems going to be very difficult to scale that if you're going to go to every single machine's kernel and going to use set host name there.
No, you don't need to do that because when you install Node N1, it's an operating system installation. That installation, if you're at level say X, and if you're at level X of the OS, the level X of the OS on N2 and N3 should also support the same framework, you're done. So, we are not going to change. So, this framework for the kernel has to be existing on each node that are interconnected in the network. One more question. go ahead.
So you mentioned about the change propagating to all the nodes, which basically instead of it pulling the information, you are pushing the information.
Yeah, that's called cluster configuration. That happens in 10 minutes. Basically, the synchronization happens in 10 minutes.
Correct.
Now, with this, we are not letting 10 minutes, we are letting it happen instantly, because N1 gets to know that I have changed, N1 has changed to N1.gracehopper, and it gets to know that instantly, the moment it happens, it sends information to N2 and N3 and says, see boss, I have changed my name, you update your database or whatever. It's not just for host name, it can be an IP address. It can be IPv4 to IPv6 or addition of IP address or anything.
So how does this change propagate to the other layers? This is just the operating system layer. How does it get propagated to the network layer, the application layer, all the other layers which are
See, we
part
are
of
already in the clustered network. We send packets, you send clustered packets. So okay, the infrastructure of the cluster you are talking, it's a multicast.
What about for the application then?
Sorry,
So in this particular example, you mentioned about the host name changing for the node. When the node changes the host name has to get changed in the application also, which is calling the services on this node. How does the application get to know that? Will that still be a reactive way of changing it, or is there anything proactive which this?
there is a
framework takes?
configuration application that is waiting for all the nodes. So here itself you have the event listener. You have the event listener sitting on all the nodes that is going to get the information.
So it's listening at the application layer
Right,
as well.
right.
This is, hello.
There was one more.
Yeah. So this is specific to AIX, right? I mean, this framework, this notification framework is specific to AIX OS.
Right.
And is there any open source kind of thing going
Yeah,
to be made available?
I did study about open source. I will talk about when you're talking about the implementation
Okay.
specifics.
And the second question is, what is the overhead of this notification framework? Because this will also have a performance impact, right?
Not much. I have seen that it's very minimal compared to what the impact it makes on the application layer for waiting or polling or whatever.
Okay.
Okay, so when you're talking about, let me continue to her question. When we're talking about similar implementation in open source, there are various mechanisms to get notified of events in the kernel layer to the application layer. Normally, we are never, okay, so the mechanisms that are implemented in Linux can be a /proc mechanism. You have the /proc pseudo file system where the kernel does write some data into one of the files for a particular process, and the process picks it up from there. So this is also kind of polling. Or there are mechanisms that would send data through sockets, or there are independent mechanisms. This will provide an integrated solution that would help you fit in any solution that you want into any of these system calls for which the application has registered to. Here you have the event listener. That is the daemon that is running on the node N1. The event listener wants to get notified of this host name change. So he goes and registers with the kernel. Now the notification mechanism can be of various types. So this is a unique factor that has been embedded into the AIX kernel, which tells that the notification mechanism that I want to go ahead and implement can be anything. I can use /proc, I can use socket kind of mechanism. However you want to notify me is what you can specify. I'll go back to the implementation details bank. So this is not specific to Unix alone. This can be to any OS. Okay, I think I've set the background firm. Now we'll talk a little bit about registration mechanism. So we have application setting on the application layer. Now this has to go and register with register notification and unregister notification with the parameters are which system call do you want to be notified of, and what is the mechanism and what is the type. Okay, the mechanism now, so register notify takes that and unregister notify takes similar set of parameters and they go and update the hook list. So what we saw in this slide was set host name is a system call. We have a hook introduced there, and we have the notification mechanism also embedded. So this is already built in. Now the framework has this built in. So what the application does, the daemon that is running in the host N1 does is just say register me for notification type for this particular system call, set host name for notification type, and that's it. You get the notification mechanism. I'll go to the, so you see the boundary, the user space and the kernel space. You have the hook list update. So notification hooks are event table. So you have the system call 1 with hook list 1, system call 2 with hook list 2, and so on. So all of this are embedded in the kernel space for the particular system calls. Now we wanted this system calls to be categorized under each component, some of them do belong to network area, some of them do belongs to a file system area, and some of them belongs to some other area. We wanted to categorize this. For this reason, we have categorized them with components, componentization. So system call 1 belong to a category component 1, and we categorize them, the system call 2 with another kind. So it can be networking, file system, clusters, or many more. So componentization of the hook list was also made. So I am sorry, I have to go back and forth because I had to set the background. The callback mechanism, notification mechanisms are can be a TCP socket domain, a TCP socket or a Unix socket or a procoffice mechanism. So you can communicate with the kernel layer and user layer with procoffice, or you can communicate with kernel layer and user layer with the event listener with Unix domain socket. So the moment you have a set host name change done, he gets and updates the Unix domain socket. The listener picks up the data from there and then he informs the cluster. Any questions? So there are callback functions.
So I have a question
Yeah.
here at your left. So you are talking about the notification framework having notifications which are mostly system related or kernel related. So any other type of notifications where this notification framework can be leveraged? This is question 1. Question 2 is that you said that the application layer listens for events. So is it continuously polling for those events?
Okay, question 2 we are not polling because we
Okay.
have the event listener and it gets the update from the kernel,
So it's a push mechanism by
from the
which-
kernel.
from the kernel to the application layer.
Through one of these mechanisms, it can be Unix domain socket, you have the connection, or you have, it can be read and write to a file of the process in the proc file system or TCP socket. So the mechanism can be, various. It depends on the application that it can choose. It's not limited to. So you have a limited bunch of implementation that you will be required to pick it up as in Linux, but this has a various set of implementation that you can choose from. Your first question, I missed it.
Yeah. So I wanted to ask that you are talking about notifications which are system or kernel related. Any other type of notifications where the same notification framework can be leveraged?
Okay, we are talking about the notification framework that has been introduced into the kernel layer for performance elevation of applications. So this notification framework is confined to the kernel framework. So it's all about the system calls.
Thank you.
7.2. So we have this, the clustered example that I was talking about has similar implementation. So callback mechanisms define various kernel to user space routines. Basically, always the application is at the favor of the kernel. It's never the other way around. The kernel never works at the favor of the application. So, but kernel to user communication can happen through any of these mechanisms. So he just goes and updates. See, I have changed from the kernel layer. If I have changed, it's something like on network node N1. Set host name is an application that changes the system name. It goes and changes in the kernel layer. Set host name is a command that changes, that calls the set host name system call and it changes. The rest of the applications in the node N1 is not aware of this. Nor the nodes on N2 and N3 are aware of this. The system itself is not aware of this, because set host name has changed it. And until and unless you go ahead and change or look for change in the node, you don't get to know about the change. Sorry?
No, my question is, what does trigger this change?
You want to do an alias, you want to change the domain, you want to change grasshopper in n1.grasshopper.india to n1.grasshopper.in.ibm.com or
Okay, so we
something
go
like that.
manually change that.
Yes, yes. So let me come back. The set host name application itself changes via the system call, and no other applications on node N1 is aware of it. So this event listener is another application or a daemon in general sense that would wait for the set host name for that particular node. So this node N1 is interested in all these events. I want to know about the host name change. I want to know about the IP address change. It's all software change. It's nothing got to do with hardware change, as I was talking with dynamic reconfiguration. It's not about the CPU modification. I'm not increasing the CPU, I'm not decreasing the CPU. It's a change in the software, but in the kernel layer that other applications are interested to be aware of. Not just applications on the same node, but here the requirement is application on the other node also need to know, because they have to keep the heartbeat synchronized and interconnected for high availability.
And one more question. So this doesn't necessarily need to be on cloud, right? I have an integrated system on my
It need not be.
on premises, so it happens there as well.
Yes. But the impact of this for cloud is very, very huge. This happens in if N2 and N3 were to be informed about the change after 10 minutes based on polling or self verification, and this happens in fraction of seconds. So the availability of these nodes and impact is very, very high in cloud. Yeah, you have a question. Somebody in the end had a question? No. So this event listener is another application, and set hostname is another application. Set hostname command is another application on node N1. So notification mechanism can be of various types. That's a very unique factor of this framework that's been introduced into AIX. It can be of any type. So the notification mechanism are not limited to what is being discussed here. Is ongoing work, and we are going to add bunch of them also. So componentization is just a high level flavor. There's no need to have componentization, but for simplicity, for sake of simplicity, we just made it that we categorize or build them in a group. Okay, callback mechanisms or special routines. So when you have the register notify mechanism, you have mentioned about the specific notification event mechanism. You have mentioned about the system call which you are interested in, the listener. There is one listener per node you can assume, or you can have 10 listeners per node as well. It depends on what kind of notifications you want to listen to. So each of this go by callback mechanism. So what this callback mechanism does is, it has callback mechanism N1 that would perform a socket, TCP socket kind of communication between kernel to user space. Callback mechanisms for each of this have been designed inside the kernel layer. This is definitely implementation specific. There can be various implementations also. So as I discussed, we have a table of hooks that needs to be plugged into the system call. So it's all the job of the person who is going to write the device driver, or who is going to write the OS layer to take best advantage of this framework by introducing his own hook list and adding them to the respective tables, so that we have a list of all hooks that has been registered. We are done with components. So we have worker threads. So worker threads are part of this thread fold, and actually these are not for the work of notifying everyone who was registered for. They are invoked by the component thread owners, and depending upon the application framework's parameters, they get communication mechanisms made for respective calls. So you have worker thread in the kernel layer, and they go and deliver particular callback that has to be fetched and serviced to the application layer. Again, we have a thread pool announcement. So we have a worker threads doing the callback job in the kernel layer. So the worker thread can be expanded. This is an enhancement with a thread pool. So you have component 1, let's say cluster, or component 2, let's say file system. They have some specific thread pools, threads, and they have a thread pool, and whatever component callback has been defined, it just go and does the job. This is a high level overview of the notification framework. So we have application 1, application 2. We have mechanism M1 and M2 that performs respective callbacks. And down in the kernel space, we have the worker thread. So you enqueue or dequeue the hook list. So it's a queue or a table. On the other hand, so application 1 and application 2 are interested in knowing the change. But on the other hand, user application has changed. There is a third application which has changed. That is the set host name command. So app 1 and app 2 wants to know of the change that is happening on the system, whereas the guy who changes the parameter or attribute of the system is app 3. That's what we have discussed here. So in this example, we have this whole thing as node N1. We have the first one. This guy is the hostname command who does the change. This goes through the hostname system call, goes to the kernel layer. He has a hook. Now he comes here and he registers it. Sorry, no. This guy has registered for an update on system call, set host name. This guy has registered via callback mechanism, any mechanism that he is interested to be notified of. So these are the daemons, these are event listeners, these are event listener 1, this is event listener 2. App 1 and app 2 wants to know of the change, but the change has actually been introduced by this guy. Clear?
Why can't we have only one event listener for a common event listener between the two applications?
Yeah, as I said, you can just have 1 or 10, depending upon your what system resilience and how do you want to break it up based on how you want to design your componentization. You don't want to have event listener for high availability merged with file system event listener, right?
So in this case, like both the callbacks are kind of same because both are having the same event listener for other set host name, right?
Correct.
Change. So basically, it's doing a common job.
Correct.
So in this case, can we just have one event listener?
So the event listener is designed by the application layer. We are not going to change the design of the person who is going to cause the change.
Yeah.
Yeah. So
But
see, this guy is going to cause the change and we are not going to touch him. This guy can be a cluster event listener, this guy can be a network event listener or a file system event listener. Now, if let's say both of them are interested in a common event, set host name, then it's all about the system design. If you have control of both the applications, go and merge it up. Nobody stops you. But the only difference is, okay, let me add to it. The only difference is, this guy has a, app 1 has socket-based implementations, and he is interested to get information about the hostname change from the kernel on a socket-based mechanism. So you would go and choose a notification mechanism of, say, your domain socket. You will just have a file, update that file, and I'll pick it up. Whereas this guy on the cluster, he doesn't have a, assume he doesn't have a socket implementation and his infrastructure doesn't fit with that. He's preferred to take this from a pseudo file system or a RAM based file system. He just wants to get an update from that. So you can say, I want to get notification about hostname change by mechanism 2, not mechanism 1. That's the difference.
Detected, right?
Correct.
So how does that happen? Because you're introducing a new piece of hardware, and how does that fall into this framework? The detection of that.
Yeah, as I said, the dynamic reconfiguration is for hardware manipulation, and this is you're talking about the network card addition. So we are not. That's all about some change in the system, and if you go, I am going and adding notification hooks. As a kernel designer, I am going to add notification hooks to certain system calls. If I am going through that system call, if your addition is falling through that system call, then definitely you go and register through some event listener, you're going to get the update. So it's required that when you're adding a device or when you're adding something, the bunch of calls, it can be a device driver open or a device driver write or whatever. If I'm getting add, read, write, it's so simple and straightforward. It's a read, write or whatever. If I'm falling through that read, I have the framework, and if I have registered to that, I'm going to get it. So it doesn't matter. Yeah. Yes. Yes.
So you'll have to introduce it at every.
No. The framework is static because the system call, I've added all possible framework mechanisms already. If you are registering to me, then I'm going to notify you. So if you are registering to me by various mechanisms, I am forced to notify you in various ways. So that's what I was telling her. If you want to merge it up and listen to a single event, the application, it's better. So it's up to the application layer developer to merge it up. The only advantage is you have multiple mechanisms embedded here. You have you don't need to touch the application that is causing the change, and an immediate instant impact. You don't need to wait asynchronously and process the data on change. So the administrator doesn't have to change this. So I am actually having short of time, so I have not covered much, but very interesting topic. Yeah, very interesting research topic actually. Yeah. So I have said here. So once all of this. So this is app 1. We are not talking about the cause. Now he populates to all the nodes to sync up. The moment this happens, all the nodes in the cloud or your clustered network is up. So the gap for downtime is almost 0. And your heartbeat is also up. Yeah.
Where it's been used currently? Any live example of where your system is used currently?
System is used currently means?
Is it deployed anywhere right now?
Yeah.
Which of your clients are actually using it? Can you give us examples?
Walmart, Bloomberg. Yeah, Bloomberg is our biggest customer.
They're all using this. Okay.
This was done at the proof of concept level, the lower layer. Okay, so
excuse me, I just have one question. Have we ever measured this performance in terms of time based, like how the notification is working? And do we have any numbers which will say, like for these many nodes, this was a fraction of time it took and communication notification it sent out?
yeah, we have internal data. We have not published it, but it's in terms of 000. Okay, the communication that happens between this layer and this layer is almost negligible. So before plugging in this notification mechanism into each of the system calls that we are going to support, we have to verify that it is not causing an performance impact for the system call execution who is not interested in the notification, right?
Yeah. Yes.
So that impact was very, very low.
Okay.
It was not noticeable. It's
Yeah.
as good as in memory, virtual memory management, you do a page in and page out and you don't know that your data has gone in and out of the RAM and disk, right?
Yeah. So just one more question. So-
Sorry to interrupt you. We have hard stop at
This light is
12:30,
bothering
so
me a
she'll
lot.
be here. Maybe you can ask your
Yeah.
questions later.
No problem. Thanks.
Yeah, it's very negligible. It is as simple as in comparison with the virtual memory management, where we have many applications running to use virtual memory with paging them on paging and all. The way in applications are never aware of the paging, right? Similar to that. It's 0.000 nanoseconds. And the communication between this guy and this guy is 0.000 nanoseconds, and the communication between this guy to rest of the nodes was very, very fast. We had an implementation that would actually synchronize every 10 seconds when cluster configuration was kicked off. This would cause problem if it is big data centered, and if one of the nodes had a change, then it would be declared as down. It was. Now it's all okay. This is very useful when you are doing IP addresses additions, not just host name. So you have dynamic update of IP addresses, IPv4, IPv6, and so on. Okay, the general solution. Here I have spoken about kernel bloat. Kernel bloat can be eliminated by avoiding individual notification services. So this is at the OS angle, OS developers angle. if OS developer had to actually introduce such a mechanism without this framework, he had to go and add a mechanism one by one. So this is eliminating the general bloat. He doesn't have to introduce the mechanism as and when he likes for each call that he is introducing in his driver, or it's something like you don't have to introduce one notification in your driver 1 and another notification in your driver 2 and so on. It's generic. You all have it and you can pick it up. It's kind of supporting both dynamic computing and dynamic reconfiguration and general in nature. Yeah, thank you. I hope I have answered all of your questions. Anything I had missed out? No.
Yeah, we still have 2-3 minutes, so
Okay. Yeah.
What was the increase in the performance, notification with the cluster size? Like, was it a linear trend or it didn't change? Like, if the cluster size.
Come back. I didn't hear the
So,
first
if the
part.
cluster size was like 10 nodes and one of them is changing, so notifying 10 against 100 and 1000, what was the difference in the time it took?
So the event would be kicked off every 10 minutes only, right?
Yeah.
So by 10 minutes, if the 9 nodes were informed, see the heartbeat happens every second. And in 1 second, if I get to know that the node is not reachable with that particular name, so your network will break and you will get a notification saying I am down. So the impact for the remaining 9 nodes is simply go and mark him, and communication to the first node who has changed it is disconnected totally. So if any migration, this makes a big impact when you do a live migration, live partition migration, or the regular migration of data. It has a huge impact. You're simply down, and the licensing value for each node duplicates because it's down. So LPM is not so simple. In fact, Oracle charges for every LPM node that is put on its backup. It's not based on license. Or even we have, IBM has a mechanism to charge a node. So it on demand, if you want to do a partition, you should have the machine in advance and pay for it. So you're paying for a machine that is already down. Okay, so it's not about just clustering, it's about various implementations, like one of the latest trend is about live partition migration, LPM.
So, is this a generic framework that we can have a hook with any of the system call, or limited system calls can be hooked?
All of them.
All of them can be hooked. So, when
all of them, wherever we have gone ahead and introduced. If you are introducing a device driver, you go ahead and add this framework. Yeah,
Okay.
even that is already.
Okay, client just need to specify which system call they want to add.
Yes,
hook, right?
perfect. Then
Okay.
the register notify, system call, type, and the
Okay.
third parameter was something, right? Yeah,
Okay, and system call should support that hook mechanism.
right.
Okay.
Okay, so if anyone has any questions, maybe she can take it later on. And we have hard stop. And so thanks so much, Vidya. Very nice presentation.
Okay.
Quite informative. So now Kalpana is going to give away mementos to you. Yeah.
Thank you.